Hello, everybody. Welcome. In this session, we'll focus on vanilla Cairo, where we'll learn about the high-level programming language, and we'll learn how to write a basic Cairo program. Now, in the next session, we'll learn about smart contracts that you can build with Cairo, but today's focus is strictly about vanilla Cairo. The sessions for this topic, we'll start with Cairo's meaning and its history. Then we'll talk a little bit about the new feature for Cairo, which is field elements. Then we'll have an interactive session, which revolves around Stark links. And finally, we'll discuss about homework and the live coding that we'll have. Great. So starting first, Cairo. It's basically a confusing name. Why? Well, mainly heard about it. Some of you maybe even traveled to it. But in our context, Cairo originally refers to new computer architecture. And this computer architecture is basically specialized and fine-tuned for validity proofs. Now, Cairo stands for CPU AIR, which AIR stands for Algebraic Intermediate Representation. The low-level bytecode executed by a CPU AIR is also known as Cairo assembly. This low-level bytecode, Cairo assembly or CASM, it's the heart of the Cairo VM. And the high language that compiles down to Sierra and then to CASM is also known as Cairo. So until now, when we talked about Cairo, we specifically referred to the high-level language, but initially or originally, it was referred to this new computer architecture, which is specialized for validity proofs. And the old implementation of this high-level language is known now as Cairo 0. So to kind of give a recap, we have the low-level bytecode, which is the Cairo assembly that's executed by the CPU AIR. Then we have the high-level language that compiles down to Sierra and then to CASM. It's called Cairo. This is the language that we'll work on, we'll learn about it, and we'll even code with it. And then the other notation, it's Cairo 0, is the old implementation of Cairo. It was mostly similar to something like a Pythonic syntax base, but this is what we call it now. Let me see if there are any questions. No. And finally, as a small trivia, Cairo is the capital of Egypt, which I guess it's super terrible for SEO. So if you try to search something on Google, for example, what is Cairo, you're going to have terrible results. You might even book a trip to there. But yeah, trying to get your answers from Google with the Cairo name is a bit difficult. So that's why we encourage you to use the Cairo book and our resources and documentation to get your answers. Okay, now going to the history of Cairo, the language itself. Initially, in 2018, we had first the Stark white paper being published. Stark basically lays the foundation for Cairo, StarkNet, and its technologies. Then in 2019, we have the creation of StarkX. We've mentioned this in the previous sessions, but you can think about StarkX as a scaling engine used by Immutable X, DYDX, Rhinify, Sorare, and so on. Initially, this was basically hard-coded polynomial constraints, mainly because due to the limitations, it was feasible to code them like this because it was only needed for perpetuals and spot trading. But then in 2020, there was the need of a new programming language, which is called Cairo or Cairo 0, and mainly it was because more features wanted to be built with on StarkX and make it more flexible. So initially, Cairo was created in 2020. This is the Cairo 0 that we refer to now. And StarkX has been rewritten using Cairo to make it flexible. Then the first white paper for Cairo was published. And the white paper encompassed the Cairo programming language, but also the new CPU AIR, the Cairo VM. And this was published in 2021. And shortly after that, in the same year, the creation of StarkNet happened, which incorporated Cairo, and it allowed to deploy and create Cairo smart contracts. And finally, 2023 is the release of Cairo 1.0, which is the new high-level programming language, also known as Cairo now. This is the language that we'll learn today. It's the new syntax. It's familiar to Rust if you've coded in Rust, and we'll take a look at it in a bit. Okay, so I would like to make an analogy here to understand better the relationship between Cairo and StartNet. So if you think about Python and Django, Python is a general programming language that you can write scripts with it and you can write anything that you want. Now, Django is a specialized set of libraries that allows you to create static websites together with Python. The same analogy goes together with Cairo and StartNet. Cairo is a general programming language that allows you to create provable programs. And together with the set of, let's call it libraries, set of syscalls and attributes, you can create smart contracts on StartNet. Now, the new concept, or basically there's a new feature that's distinguishable from Solidity, let's say, in Cairo. And this new concept is called field elements, or felt for short. Cairo's default data type is felt, or the full name is called felt252. And basically, this is 252 bits for storage. Now, it's important to note that compared to Solidity, the default type for Solidity is unsigned integer, or short U256, while for Cairo is felt252. Two different aspects. One, it's smaller size, and two, it's a felt type or a field element type, which introduce a lot of interesting things and properties. The first property is basically a file can be represented between a value from 0 to p, which p is basically a large large prime number. And this large prime number is basically for the start. So this p is basically the true number of p. It's there. The calculation is p equal to 2 to the power 251 plus so on and so forth. But basically, you can think of this, it's an extremely large prime number. But it's smaller than 2 to the power 250. So in essence, this large prime number will fit 2 to the power 250.
There's a question about from Temitop. Any reason for that specific number for felt?
So the specific reason, you'll find more about it in the Cairo white paper, but it's due to some mathematical constraints and flexibilities to allow arithmetic operations. But if you want to learn why specifically the felt252 has been selected, I would definitely suggest you read the Cairo white paper. But it's mainly due to the mathematical flexibilities and constraints working with field elements. Okay, let me mark it as answer live. Okay, now another interesting property is that all arithmetic operations are modulo p, which means that a felt can overflow and underflow. So what this means is that if you're trying to do arithmetic operations such as addition, multiplication, or subtraction, for example, in your contract, you have this large prime number p stored in your storage, and then you add a +1 to it, it will overflow, and then it will wrap around and start from 0 from the beginning, and will be represented as modulo p. The same thing goes for the underflow. So if you have in your storage a felt with the value 0, and then you subtract 1, then it would underflow and it will be represented as modulo p as the largest number. Another interesting thing is when it comes to division. So there's an important aspect here. So standard integer division on normal CPUs happens as expected. When you divide 1 by 2 on normal CPUs, you will get either 0 or 0.5. But with this new CPU architecture, when you do felt division, something interesting happens. So we have 1 divided by 2, which are 2 felts. And this basically will be represented as P, which is the big prime number, plus 1 divided by 2. And this will not be 0 or 0.5. And why this happens is that with your standard integer division on your normal CPU, it could be satisfiable or unsatisfiable depending on the case. But when you do felt division with the new CPU architecture on Cairo, this will always be satisfiable because this will be represented by this large prime number. Okay, no questions. Now, obviously, when you try to develop a smart contract or a program, overflow and underflow could represent an issue, especially if you're developing a DeFi application where overflows could potentially be of risk. So the nice thing about this is that we have, in Cairo, we have something called signed and unsigned integers, which solve this problem of overflow and underflow. These unsigned integers are represented by U8, U16, and it goes up to U256. And we have something called U size, which basically is standard for, by default, it will represent it by U32, but you could take any type of size. Now with signed integers, they are supported on Cairo, but please note they're not supported on StarkNet yet. So you can use them in Cairo, but not on StarkNet. The aim of this session is to learn Cairo, and we will do this by using an interactive tutorial, which is called Starklings. Starklings initially was created by Fremi, this guy and the first guy. And then basically, so Starklings is something similar to Rustlings if you're coming from a Rust background. And it's a super interactive tutorial where you can code along, you can read hints, and then you can compile the app and then, progress throughout the homework. Now we have something, initially this was a GitHub repository that you had to kind of like clone and then install different dependency. But we have something called Starklings app, which is all this process, and it's basically a web app that you get on and then you just start coding. And this was created by Damien, the image below. Now, currently the app project is maintained by the community. So if you're interested to participate and contribute to this project, you can find it on OnlyDust. Or if you're interested in contributing or participating in other projects, I would advise to give it a look at OnlyDust. So for the live coding, the Starklings app, you'll have to go to the Starklings app. It's just click here and the web app will be open. What's important is to connect your GitHub account, as there are two things here. It will save your progress of your session, and also it will help us to know if you're successfully finished your homework. And finally, what you have to do is read the task, use the hints, use the Cario book, and compile the code and solve the exercises. So the aim for this session is hopefully we'll solve half of the Starkling. Make sure to log in with your GitHub account. So this is the Starklings exercise. And then once you log in with your GitHub account, you'll see all of these green things, and you'll see that this basically means I've solved these exercises. So make sure to be logged in. I'll actually log out. Don't do this. I'll clean my cookies because I want to start initially from the beginning. So I'll have to clean my cookies here, and then I'll do it like this. It'd start from scratch, so I can start blank with you. So first things first, a couple of things that I want to mention. So this is just the Starklings original Starklings. It's a repo, but this is our main focus. We have our Cairo book that we'll use throughout the session. I'll share this in our chat. And finally, yes, if you're interested about like the ins and outs of the Cairo programming language, we have the Cairo GitHub at Starkware Libs Cairo, but this is not essential at this point. And there's one more thing that I want to mention. So there's a chatbot that will help us, throughout your journey, that you can learn about Cairo. So you can type of questions, it's like, what is Cairo? And then you're gonna get an answer out of this chat. So you can use it as an extra tutor to help you throughout this process, but it's not necessary. Okay, so we're ready to start. Let's do the exercises. So the first intro one, it says, welcome to Starklings. You have a smart introduction. What you have to do is you have the code on the right, and then you have here below two buttons, the get hint and compile. So first initial exercise is just a main function that is empty, doesn't include anything, but just to know how functions work in Cairo, this is how you define them. So you define them with fn keyword, you have main, and then you have the parentheses where basically the input parameters go, and then you have the code logic between the curly brackets, right? So this function should compile, it works fine. You can hit compile, or you can get the hint, and you can get hint, but this time we don't have any hints. But anyway, let's compile it. Let's see if it works. Okay, great, we have it. Nice, we can progress to the next exercise. So the question is, this exercise won't compile, can you make it compile? So we see that it's an empty block here, there's nothing written. What you'll have to do basically is just define a function and make it compile. Let's see if there are any hints. No, we don't have any hints. I'm unlucky today. Okay, so then let's define a function. As you remember, we did fn for defining the function. We'll define it as main. We'll open the two parentheses where, input parameters go, and then the curly brackets where the main logic will go here, right? And then we'll try to hit compile. Okay, great. Now we go next. We have variables one. So in this exercise, again, the aim is to make it compile, but let's analyze the code. So initially we have a main function, and then here we have x equals to 5. And then we have a print len, which is print line, and then it prints the actual value, right? So if I try to hit this compile, it might throw an error and say, oops, something went wrong with the code. And it says that this line x equals file identifier not found. Why is that? Is because we have to define the variable, right? So this is just what we're doing here is just assigning a value, right? But x doesn't exist. So what we need to do is define the variable x. So to define a variable x, you use the keyword let. This is how you define a variable. And then we do the assignment of 5, okay? And you can also hit get hint to see the hint. So the hint here is the declaration on line 2 is missing a keyword that is needed in Cario to create new variables bindings. So the keyword let allows you to create these bindings. Let's hit compile, and we managed to solve this. Okay, on to the next one. Variable 2, we have to compile this. So if we analyze the code, we have let x. So we just, define x, but we don't assign anything to it. And then we have an if statement, which checks that if x is equal to 10, then it will print the following statement. So it will print x is 10. Otherwise, if x is not 10, it will print x is not 10. So what we have to do here is basically we are defining x, but we're not binding anything to it. So in this case, you can say let x be equal to 10, and you can hit compile, and then this will be able to manage to compile the project or the code. Or in this case, you can also say something else, 6, and you can hit compile again, and it should work. So what we did here is basically we assigned the value 6 to x, and then this if statement will go through this criteria. Okay, next one. Variable 3. Now in this main function, we have let x, and now we can see we defined a data type. So this data type is the felt 252, which we talked about in the presentation. This is the 252 field element, and we don't have any value assigned to it. And then in the next line, we have print line x is, and then this is basically just a placeholder, and then we put the value that we want to print there. So if I try to compile this, it will throw out an error as expected. You see that basically let x felt to 52 is something like an issue there. So you can go for a hint here in this case, and then you can read the hint. It says that we created on line 2. So we have a variable binding that we've created on line 2, and we're trying to use it on line 3, but we don't have any value to it. So what we have to do is basically assign something to it. So in this case, let's assign, you can assign a number, 5, right? Or you can assign a felt, or a short string, which is represented by these single quote. And this is how you would kind of like do short string. So character, let's say, right? Okay. And then this compiled. And just for the sake of it, I can represent it as 2 as well. And this will also be a felt 252 because this is how we explicitly define the data type for x. So this exercise is basically, so it says let x be equal to 3. And then we have print line, x is 3. And then here what we try to do is reassign a new value to x. So if I try to compile this, guess what happens? It gives an error, right? And mainly because what you have to think about is everything in Cario is immutable by default. So whenever you define let x by equals to 3, this variable will be immutable, which means that I cannot change the value here. So what happens here is that to make a variable mutable, there's the keyword mute, and you have to define next to. So this is how we do. We define let mute x equal to 3, And then this will allow me to actually change the value. So if I can compile it again, it will actually work. And if I hit the hint, you're gonna get some additional help. Let me hit compile. Okay, let's go to the next one. So in this, we have variable 5. We're almost done with this section. So in our main function, we define let number equal to 1, and then you can see there's an underscore U8. So this is another way to specifically define the data type for this variable. Notice before we had something like this, let number U8, right? But now you can also define it as 1 underscore U8, and then this will automatically be unsigned 8, right? And then what happens here is that we print it, and then we're reallocating for the number the value 3, and we print it again. What basically means here is that there's a concept of variable shadowing. So if you hit the hints, you can read about this, and it says, unfortunately, so we learned today that all variables are immutable by default, and there's something called shadowing, and we can see an example here. So let me actually, it's I think a good time to open this link, pass it here. I haven't passed it here correctly. Okay, like this. Okay. And this you can read about variables immutability and then shadowing. You can also search about shadowing. So shadowing, basically what happens here is that if you define X in the first line and then you define X again, it basically shadows the previous variable, and then you can reuse it, right? So if we go back here, if we add the let keyword, now this is something that we refer to shadowing, which basically means that we first define a number, we assigned an unsigned integer 8, and now we are shadowing number again, and then this will be basically a felt type, because again, by default, all values are felt to 52. Let's hit compile. Okay, moving to variable 6, we'll have to compile this. So what we notice here is the introduction of a new data type, which is constants. And then we have the main function, and we print this number. So there are a few things about the constants that you have to think of. So first off, constants are immutable by default. You cannot change them, even if you want them. If you want to use the mute keyword, it would fail. So they're immutable by default. Second, they always lie at sort of say global scope of the function. And a few things about constants is that they will always expect the data type. So you cannot define a constant number equal to 3 because you haven't defined the data type. So if I try to compile this, will obviously fail. I'll have a compilation error, which means is that first I say const number, and then let's say this one will be a felt to 52. And then this one, because we're passing an unsigned 8, we'll say that this is an unsigned 8 as well. So let's try to compile this. So primitive types, what we see here is basically, let's analyze the code initially. So we define is morning be equal to true. Notice that this is already a Boolean type of data type. And then based on this, we're doing an if statement, and we verify if is morning is actually true, then print good morning. And then on line 9, we'll have to finish the rest of the line. And we have an if statement that checks that is evening equal to true, then print good evening. Now, let's use the get hint a little bit to see what happens. Man, I'm really unlucky with the hints. I always hit the get hint whenever there's no hints. Anyway, so what we have to do is focus on line 9, which basically means that we have to construct a variable that's a Boolean type. And the name of the variable should be is evening. So is evening. And then we have to assign a value, and then the value for this, well, for me, it should be true, but for the sake of, I don't know where everybody is, but let's say for now it's false. And this if statement won't print the good evening because this evening is false. So let's hit compile. Obviously, it doesn't compile because remember, you always have to add the semicolons at the end. And that's how you state the end of the line or Cairo. Okay, it compiled. Let's go to the next one. Okay, this is a little bit bigger exercise. Let's see. I'll try to split this so it's readable. So let's see the comments. So first, a short string is a string whose length is at most 31 characters and therefore can fit into a single field element. Remember, the field element is of 252 and each character is 8 bits. So that's why only 31 characters fit into a single field element. Short strings are actually felts. They are not real strings. And note that single quotes, so the single quotes that are used for short strings. Initially, we have let mutable, my first initial being equal to C. And then we check that this, that we have a is alphabetic is a function here below that checks if C is either alphabetical. Otherwise, we have a different function is numeric that checks if the value of my first initial is numeric, or otherwise it will print it's neither alphabetic or numeric. These two functions lie here below. You can check them first. So it's not necessary to understand them, but just for the sake of example, we have the function is alphabetical. This is something reference. It's called the reference because we're passing the reference of the variable itself because it's mutable. And then what happens here, we just return a Boolean type, but it's not necessary to go into the details of it. So this first initial block is done and it validates my first initial variable. And now what we have to do is line 20. It says, let me split this, finish this line like the example. What's your favorite short string? Try a letter, try a number, try a special character, try a short string. So let's do that. So if we check the first example, we notice that we have to state as immutable because when we're passing this variable to the functions, we're passing it as a reference and we use the variable. So what was the name of the variable that, oh, so it has to be your character, right? So if you check the function is alphabetical, we reference your character. So this is how my variable should be stated, your character. And then here we can assign any type of character. So let's, again, single quote, right? That's how we define short strings. And then let's see, my initial character like of my name is R. So let's try R. And then if we check the if condition, it should print alphabetical. So we try to hit compile. Let's see if this works. Of course, because I forgot the semicolons at the end, it successfully compiled. Let's see. Deconstruct the cat tuple to call print on each member. So in the first, on the second line, we see that we have an assignment, let cat equal to, and then this is a parentheses. And in this parentheses, there are two different values. First, it's a short string, and then we, which basically it's a felt, and then we have 3, which is another felt. But on the line 3, we need to create a pattern so that we could print name and age individually. Line 2, cat, this is what something called a tuple. Tuple basically can consist of different data types, so it can foster different data types. But one thing about tuples is that once you define it, you cannot change the size of a tuple. So here, what we have to do on line 3, we have to take this tuple called cat, and we have to deconstruct it into the individual variables that we want to. So to do that, you could say, we open to parentheses, we say name, because this is the variable that we use on line 4, and then we say age that we use on line 5, and then we assign the tuple itself. And this is how we can deconstruct tuples. I'll press the get hint as well. Hopefully I'm not getting unlucky this time. So you have an explanation about this. And also you can check the Cairo book about tuples. Let's see. So this is where you'll find more information about tuples. You can also define the data type that you can expect for tuples. So in this case, we have the tuple tup. And then for each variable, we expect, for the first variable, we expect U32, U64, and then a Boolean. And then you can see here the deconstruction of the tuple. Okay, let me compile this. Now let's go to the primitive types. So we see here that we have to modify this. Don't modify the values, just the types. So we need to modify the types of these values. So initially we're summing two big numbers, which is 252 and for the unsigned 8. And if you're checking what's the maximum limit, sign 8 is basically 256, but in this case, we count 0 as well. So when you try to sum these two numbers, it will overflow, right? And we'll have to modify the types here. So what we have to do here is we can expect, we have two functions that we can use here, and we'll use the felt, and then we'll use the unsigned 8. So this one, the felt, what we have to do here is basically we have to convert the 8 to a felt to 52. And because unsigned 8 would always fit into a felt to 52, what you can do is you can use the into function, which will cast x into a felt to 52. Now, when you're trying to cast felt to 52 back to U8, you're not 100% sure that this will entirely fit into an unsigned 8. So for that, you have to use try into, which is basically a safe mechanism, which will give you an option. And then based on that option, you can do, for example, a pattern matching that we'll look into the future in the next few exercises. And then you can say that if this function ran okay, and then you can return the value by unwrapping it, or if it's an error, you can specifically say a certain error message. Now, I'm just changing this function to be able to sum these two numbers. So I'm using the convert to felt, and then I'm just returning the felt to 52 type. And here I'll also expect the felt to 52. But this is more to get accustomed with the different types of unsigned integers and to do casting into different sizes. So if we test this, it should work. Okay. So what we have here, so let's see, integer types implement basic comparisons and arithmetic operators. Felt to 50 operations should be avoided where possible, as they could have unwanted behavior. Yes, so again, just to recap, felt to 52 can overflow and underflow, but if you use integer types, they have protection from these overflows and underflows. So what we have here initially, return the solution of this polynomial, so to say, so x to the power of 3 plus y minus 2. And then we have this polynomial function. It has input size u size, and then it returns a u size back. So u size by default is an unsigned 32. We have to fill this. So what we're doing here is, well, we have to do the calculation of the polynomial. So to do the calculation, so we notice that we return res, right? So what we do here is basically define the variable res, which is short for result. We say equal to, and then we have to construct this calculation. So to construct this calculation, I guess what's important to notice is that maybe you're used to do this type of calculation from other programming language, but unfortunately, Cario doesn't support this operator. I mean, this operator is being supported, but it's for something else, and I'll get to that in a second. So actually do the power of 3, you have to do this, x times x times x, and then we add the y, and then finally we do the minus 2, we do the subtraction, right? And then if I test this function, it should say great, correct. Now, let me go back to the Cairo book. Again, use it as a Bible. It helps. It has a lot of helpful information. And if we go to the appendix, you can see what operators and symbols are supported. And in this case, I'm looking at this hat. I forgot the name of it in English. This one. So this is basically a bitwise exclusive OR operator, right? So it's not to the power of 3, it's basically a bitwise exclusive OR operator for two expressions. So if you're interested to learn more about the different operators, you can check this section. Cool. Now let's do another exercise and then we'll wrap up with the live Starklings app. And then for homework, you can do the rest of them. Here, let's read what's our task. So Cairo has native integer types, example, U8, U32, U256. We already discussed about this, and we always have to take care of the overflows, yes. So let's try to use them. So again, wherever possible, make sure to use these operators rather than using a felt. It's good practice. So we'll have to do the modules. So again, to do the modules, you have to define the let result or let res. equal to, and then we have x, and then the modulo operator, which I think it's quite common in every programming language, is the percentage sign. And then you have x% y. And then if we go to operators, I think this is small enough, or where is it? Here. So this is the arithmetic remainder. Okay. Now to do the floor division, let's try to do the floor division. Now let res equal to x divided by y. And then for the multiplication, it's already, oh no, I have to, let's do the multiplication. Let res equal to x times y. And then if you want, if you're having issues with the exercise, you can always hit the hint button, and then you can see the actual hints here. So for multiplication is the percentage sign, division is the slash, and then the asterisk for multiplication. Let's try to test this. And voila, great, we managed to do this. I think so far we did quite a few exercises, so the rest is homework. Hopefully like this was helpful. For the next part, I would like to start doing the installation of the dependencies to prepare you for the next session, which will involve building smart contracts. So you use this knowledge of learning Cairo, and you'll use Cairo to actually build some smart contracts, and that's going to be interesting in the next section. Let's switch back to our installing dependencies. So you don't have to follow along. It's you can also do it after the session. It's more to have you prepared for the next session. Here in the slide, you'll find the dependencies that we'll need. So first one is an ASDF library, which is basically something called as a version control that allows you to switch between different versions of certain libraries or package that you add. Then we have scarb, which is similar. If you're coming from a Rust background, it's similar to Cargo. It's package manager that allows you to do various things for Cairo, compile contracts, add dependencies, scripts, and so on and so forth. Then we have StarkNet Foundry, which allows you to build test suites for your smart contract or Cairo code. And then finally, we have the Cairo language server that gives you these syntax color. So let me spin up my virtual machine because I'll start from scratch as well. So you can get accustomed to what we need to do. I'll take this tab onto another screen, and then I'll start doing ASDF. Okay, so first I have to install ASDF. I'll go to the ASDF getting started, and depending on what type of machine you're using, in my case, I use a Linux in this example. There's different instructions on how to install on different machines. So initially, you'll have to have Git installed. So to do that, let me know if this is big enough. Okay, sudo, or not necessarily sudo, but a sudo app install Git. So now I'm installing Git. I'm just checking if I have Git, and I have Git installed. Okay, so again, to install Git, you just have to say sudo app install Git, or depending on what type of machine you have, you can follow the examples here. So for those with Windows, I think you have to use something called WSL2 or something like that, but you have to install the Linux dependencies, and basically you're allowed to do these commands as well. Okay, now next up, what we have to do is basically download ASDF. So in my case, I'll clone this repo. Just give me 1 second. So git clone and git clone that repo. Okay, I managed to clone this. And finally, what I have to do is just add it as my dependency. So again, if you're using a Mac and you have Homebrew, you can install with brew install ASDF, or you have Pacman, you can do this as well. Now, I have cloned my repo, but finally what I have to do is just, I have to add my bash or the paths towards this ASDF. So to do that, I'll go back here, I'll see nano, and then I'll go to my bash rc, and then here at the end, I'll add the ASDF paths. So I'll copy this, I'll add it here, and then I'll copy this and add it here. And I'll save this, and that's it. For those who use, for example, Mac, you have the ZS, and then you basically go to your ZSHRC, and then you'll have to add these paths as well. Okay. Now what I have to do is either you exit the terminal or you just use source which basically will apply the new settings. And then now I can use the ASDF to see if I successfully install this. And I typed ASDF and you see that I've managed to properly install this. So first step is finished. Now we are moving to the next step. The next step is scarb. So if you follow the link from the slides, it's this one, and we'll install. So the reason why we need ASDF is because we'll be able to seamlessly install scarb, and we'll be able to switch between the versions extremely simple. And this will be just a super, like a very easy and very good developer experience. So to install it is pretty simple. You take this line ASDF plugin add scarb, you plug it into your terminal. This adds the scarb repository. Simple. And finally, you can install scarb, right? So ASDF installs scarb, and we're install latest means that the latest available version. So in this case, it's 2.6.4. Or if you want to install another version, so let's say 2.6.3, you can do that as well. Okay. And now one final thing is that you have to set the global version for your scarb. It's either you say the latest. So I'll grab this line, I'll put it here. And then now I can actually check if my scarb has been installed by calling scarb -- version. And I'll see that scarb is actually 2.6.4. But let's say that my project uses 2.6.3. How I do that, how I basically downgrade the version. Well, you can use the same command as previously, but instead of saying latest, we say 2.6.3. I hit enter. And then if I do scarb version, if I pronounce it correctly, you'll see now I'm on 2.6.3. So you see the seamless transition between downgrading and upgrading scarb. So that's why it's a super powerful tool to use. And I do advise to use it as well. So again, I switched to the latest version. I should be on 2.6.4. Okie dokie. Now let's see the next step. The next step is to install StarkNet Forge or StarkNet Forge, StarkNet Foundry. The reason why I said Forge is because StarkNet Foundry comes with two different things. So it's StarkNet Forge and StarkNet Cast, which are two different, let's say, libraries. Forge is for testing, and Cast is more of a DevOps managed package that allows you to declare and deploy contracts. So let me add this to my ASDF. Again, I copied this line. I'm just adding it. We have to install the latest. Okay, installing the latest. And finally, I think I'll have to set as global SDF, global StarkNet. Okay, so again, I mentioned StarkNet Foundry comes with Forge and Cast, and you can call this as SN Forge, and then you can say version. You see is 0.23 and SN Cast version 0.23. Now, we installed all the necessary dependencies. It didn't took me a lot of time. It's just ASDF has to be installed. And then from there, it's easy peasy. You just have to install the packages. And then you can switch between the versions. Now, for the big guy, I have to install an IDE. So for that, I'll use yes. For my specific virtual machine, I have to download a specific version of it. So in my case, I have to download the ARM64, but I guess for you, it's Visual Code. If you're on Windows, it's fine. And on MacBook, if you're using MacBook, it's fine as well. So let me install this quick. I have to plug in my password. And now, like, we installed the IDE so that we can work with building Cairo contracts or Cairo code and then StarkNet smart contracts. And then here we'll just install the syntax language so that you have your syntax. So let me restart my terminal so that code is enabled. So I can, with Scarb, initially, just for the sake of example, I'll just go into my desktop, and then with Scarb, I can say Scarb new, and then let's call this new Basecamp. And then this will create me a new Basecamp folder, which initializes Scarb in that. So I cd into this, and now with code, I should be able to open this, right? Yes, I trust the authors, and this is my VS Code. Obviously, I go for the dark mode. And then here you can see just the simple Cairo code. It's a simple Fibonacci sequence, and then currently it's not color-coded, but to fix this, what you have to do is to go to the extensions and search for the Cairo 1. It's very important to install Cairo 1.0 and nothing else. So this Cairo is for the old version of Cairo, so be sure to install 1.0. This is the one that you're actually after, right? So again, Cairo 1.0 is the one we need. Install this, And not sure if it works by default, but let me actually restart my terminal since I've installed something. And let's see. And now you can see that the language server actually works. And then we have the color coding as well for our Cairo code. So that's a wrap up. I hope you enjoyed this session where we started with a little bit of theory about Cairo, its history, and some of its technicalities. Then we switch to an interactive exercise, which is Starklings, where we learn how to code in Cairo and we learn the basics. And finally, we did some pre-installation steps for the next session, which are smart contracts, where we installed the necessary tools and development kits that we need to start writing smart contracts. Make sure to solve the rest of the exercises, and thank you again for joining this session, and until the next one. Cheers.